So I've worked through a lot of examples that will resemble your homework problems. I have one more type of example that I want to cover. And that example looks like this. Find the values of the constant a so that the function f of x will be continuous for all values of x. And so my constant a is given this right here. So this is a piecewise function. I have one piece separated to the left of 4, and I have a second piece separated to the right of 4. And we want to make this, we want to know what this value needs to be so that my function is continuous everywhere. Well, let's look at each piece individually first. So let's look at my first piece. X is less than 4. That is given by 1 minus 3x. Well, what type of function is that? That is a polynomial function. More specifically, it is a linear polynomial function. So we know that polynomial functions are continuous everywhere, so we know that this function is definitely continuous everywhere less than 4. Let's move on to the second piece. That's defined when x is greater than 4. And if we look at it, even though we don't know what a is, we still know that this guy here is a polynomial function because a is a constant, meaning it's got to be a number. So this is a quadratic polynomial function because it's degree 2, and we know that polynomials are continuous everywhere. So this function is guaranteed to be continuous everywhere greater than or equal to 4. So if it's continuous everywhere to the left of 4, and is continuous everywhere to the right of 4, basically the only place we need to worry about it to be continuous for all x is what's happening specifically at x equals 4. So if we look at the visuals that could possibly happen here, again it's the same that we saw in the last video. We can have this happening where our two pieces don't match up, meaning it wouldn't be continuous. Or we have this happening where two pieces match up and it is continuous. So basically we want to figure out our constant a, so this thing here is guaranteed to happen. Our two pieces match up in the middle. And they match up to give us this y value here. So we need to make sure that these two pieces match up. Well, that means we just have to make sure that these two pieces are equivalent to each other. So my left-hand side, my 1 minus 3x polynomial, has got to equal my right-hand side, my ax squared plus 2x minus 3. Now, this actually still may seem a little bit more difficult than it needs to be. This is telling me that these two pieces have to match up for all x. But I know for all x we are okay with the exception of this x value here. I'm only looking specifically what's happening at 4. So all we have to do is plug in that 4 for each of these x values, and then that will tell me that these pieces will match up at 4. So I have 1 minus 3 times 4 is equal to a times 4 squared plus 2 times 4 minus 3. So now all I have to do is solve this equation, really easy equation, figure out what a needs to be, and that's going to give me exactly what I want. So on the left, I have 1 minus 12, or negative 11. On the right, I have 16a plus 8 minus 3, or 16a plus 5. To isolate my a value, I subtract 5 from both sides. That gives me negative 16 is equal to 16a. To isolate my a value, I just divide by 16. And that tells me that a is equal to negative 1. So if I substituted that back in for this a value here, that means my two pieces are going to match up when x is equal to 4. And if you don't trust yourself, you can always check it. So let me substitute in back a equal -1, and again, x is equal to 4. So on the right, -1 times 4 squared plus 2 times 4 minus 3 gives me a -16 plus 8 minus 3. -8 minus 3 gives me a -11. That's what's happening on the right-hand side of this equation, which matches up with what we already did over here on the left-hand side of this equation. So that means at 4, my two pieces match up, and that gives me this visual right here, where my two pieces match in the middle. So we have just figured out what our constant A is, and so we have figured out the answer to this problem. This is the last specific example that I have over this homework, and now you should be able to finish any type of homework problem talking about continuous functions.